Kubernetes best practices from Doremonlabs. So, first of all, what is Kubernetes? Kubernetes is the tool that orchestrates the infrastructure to handle the changing workload. It can scale containers across multiple machines, and if one fails, it knows how to replace with a new one. A system deployed on Kubernetes is known as a cluster, and the branch of the operation is known as the control plane. It exposes an API server that can handle both internal and external requests to manage the cluster.
Hello everyone, welcome back to Doremonlabs YouTube channel. Today we are going to discuss about an important topic, I would say, that is best practices to be followed in Kubernetes. So as we know, the containerization changing the face of our IT architecture, and Kubernetes has become the most popular tool in the DevOps domain. According to CNCF's 2020 survey of 1324 respondents, showed 83% uses Kubernetes in their production environment, which helps them to orchestrate containers by automating their deployment, scaling, and load balancing needs. Although popular, Kubernetes is not necessarily easy to work with. As your Kubernetes cluster grows, definitely there will be increasing complexity as well. So to get the most out of your growing Kubernetes cluster, today we are going to discuss about, and we are going to recommend you to follow some best practices in the Kubernetes. So as you see this slide, you will see there are 9 best practices we are recommending. Download the latest version, use of namespaces, maintain small container images, set resource request and limits, use readinessProbe and livenessProbe, secure your Kubernetes with security policies, network policies, and so on. Then auto-scaling. The second last is monitoring your Kubernetes cluster, and the last will be auditing audit logs. So let's just start with first one, that is download the latest version. So you must always have the latest stable version of Kubernetes in your production cluster. The new releases have many updates, additional features, and most importantly, patches to previous version security issues. So what latest version ensures to you? So it helps you to keeping your cluster away from all the vulnerabilities that might be there in the previous version and they got solved in the next version. And also you get all the updated features, so you don't miss out any support from your older one and or any unsupported version. Okay. The next is use of namespaces. So by default, there are 3 different namespaces already there in Kubernetes at the beginning. That is default, kube public, and kube system. You already know about kube system, like in that all the Kubernetes related pods there, that is kube DNS, then kube proxy are there in kube system, and we can use default and kube public for our general application deployment. But namespaces are very important in organizing your Kubernetes cluster and keeping it secure from other teams working on the same cluster. Let's have an example. If your Kubernetes cluster is large, let's suppose you have hundreds of nodes are running and multiple teams are also working on it, you need to have separate namespaces for each team. For example, you should create different namespaces for development, testing, and production teams. This way, the developer having access to only the development namespace and won't be able to make any changes in the production namespace, even by the mistake. So what ensures you if you use the namespaces? So first one is multiple virtual cluster boundary within one physical cluster. As I already told, there will be a Kubernetes cluster which may have hundreds of nodes, and all 3 of your environments will be running into that development, staging, and production. So you can treat each namespace as a multiple, each namespace as a virtual cluster boundary, and also provides you scope of naming as well. So you can provide some meaningful name to your namespace, like as we see development, testing, and production. So this will be the 3 environments running in the single cluster, but will be isolated because of namespaces. So let me just show you diagram how the namespaces will be look like if you have 3 different namespaces within the same cluster. So this is the diagram you can see. So the namespace they will be there in that pods and services related to dev namespace will be running, then staging and the production, and so on. Let's move to next best practice, that is to maintain small container images. So most of the developers make a mistake of using base images like CentOS and Ubuntu, which is already having size of 700 and 800 MB, and again which may have up to 80% of packages and libraries that we definitely don't need. As I said, base image, if we go for base image like Ubuntu and CentOS, definitely those already will be having 500-600 MB of size, because there will be so much of unnecessary packages and libraries will be already installed there. So why we should have a small container image? Because to make our builds faster, we should have small images. Images should be in a small size. So because of that, build will be faster, your deployments will be faster, because at the end Kubernetes downloads that particular image from uh, image registry. So that also fastens your process if you have smaller container images. So as a best practice, you should go for Alpine images, which are almost 10 times smaller than your base images, and only add necessary libraries and packages as required for your application in that particular image. So the image size will be as much as possible will be a smaller one, like 200 to 300 MB. Okay. The next is set resource request and limits. So this is one of the important best practice I would recommend you to follow in your Kubernetes. So what happens is, like, if you do not have resource limits and resource request enabled on your pod, so what it will do, like, let's suppose there is one pod running, and because of heavy resource utilization, it may consume whole resources of that particular node, and it will end up like you won't able to deploy any other pod on that particular node, even if that node has capacity to host that pod. So for that, uh, we should have resource request and limits. I also here mention, like, to avoid cases where single team or application drains all the cluster resources. So that is what I was telling. Your single application may drain all your cluster resources. So set request and limits for your cluster resources, especially CPU and memory. Doing so limits disproportionate resources uses by application and services, thereby avoiding capacity downtime. So if we already set resource limits and resource requests, definitely we will able to avoid capacity downtime. And yeah, so that is the reason resource requests and limits are so important. Like, let's take an example of Java. So Java consumes more memory, because that is memory intensive application. So we can have, like, we already know, like, this particular Java application going to need this much memory only. So give uh, why should we allow that Java pod to consume uh, all resources from that particular node? We will limit that particular memory only that we know. So to set the request and limit on container, you may use, let me show the object YML, like how you can set these resource requests and limits. Okay. So here you can see, like, we will have a resources patch. In that we will mention requests and limits. So in request we are mentioning, like, that particular pod able to request for 128 MI, that is 128 MB, and CPU 400 M, that is zero point 0.4 core of CPU, and limits, like, that particular pod only goes up to 256 MI, that is 256 MB, and for CPU it can goes up to 800, that is zero point 0.8 core only. After that, if it is try to uh, if it is get overutilized, like it almost crosses limits, definitely that pod will go into evicted, and again that pod will come. So this is how we can avoid that capacity downtime using resource requests and limits. The next one is again the important one, that is use readiness probe and liveness probe. So with readiness probe for production apps, Kubernetes checks if the application is ready to start serving traffic before allowing traffic to pod. This essentially indicates whether a pod is available to accept traffic and respond to requests. So you got to know, like, uh, before starting, like, let's have example, there are two pod, one pod is trying to communicate with another pod. So it should not happen like as soon as this second pod comes up, this first pod will start trafficking to that particular pod. So it may end up in, like, that pod is not up and running, and we may miss some traffic or miss some request because of that. So with the readiness probe, that readiness probe will have a health check. It will check for that particular pod whether it is able to uh, catch traffic or not through readiness probe. And the next one is liveness probe. So Kubernetes performs a health check to ensure the application is responsive and running intended. So as you by just words you got to know, like it will do health check to that particular pod. So it will just keep on checking like that particular pod is perfectly running or not. If it is not running, so it will go into restarts, and then your kubelet default policy will restart that container to bring it back up. Okay, so this is the important best practice I would recommend you to follow in your Kubernetes. Now the next and most important, I would say, like we can have a separate video on this secure Kubernetes only. Like Kubernetes is complex platform and require extensive configuration and management. To keep Kubernetes workload safe, especially in production environment, you need to address key architectural vulnerabilities and platform dependencies. So there are several security best practices which I have listed over here, and definitely we will need to have a separate video on these security best practices only. So let me just walk you through one by one what security best practices we can follow. So this is can be, I would say this can be another topic for our next video, like security best practices for Kubernetes. Right now we are just talking general best practices for Kubernetes, but definitely we can have a separate video on security best practices for Kubernetes. So the first is image scanning. So at the end, in a Kubernetes, application run as a container, and container needs image to be run. Okay, so you should have image scanning in place, so there will be no vulnerabilities with your image. So any hacker will not able to find that particular vulnerability and will able to introduce your system. Second is run container as a non-root user. So your application container should not be run as a root user, because it again create a weak position, create a weak entry point, and definitely hacker will able to access that container directly. Okay, the third one is set RBAC permissions on a Kubernetes resource. So RBAC, role, so you already know. So third one is set RBAC permissions on a Kubernetes resources. So RBAC is nothing but role-based access control. Okay, so what it tells you, like you should not have all permissions to a single entity. Let's take a small example, like developer. Okay, so developer only able to let's suppose at the end who works on Kubernetes, developer is the entity who works on the Kubernetes, right? So developer should not able to delete any of the object from Kubernetes. He or she only should able to read those objects, not to delete. If he or she wants to see the logs for that particular node, that permission should be given to that particular developer user. So this can happen through RBAC permission. So we can set RBAC permission, in that we will be mentioning that this particular users set of users will have only read access on the Kubernetes objects, and enable to see the logs only. Rest of the permissions will be restricted to them. So this is RBAC one. Then we can have IRSA as well. That is IAM role based service account. So that particular pod, let's take an example. Let's go into AWS, where we can implement IRSA as IAM role based service account. So that particular pod only will be having access to that particular AWS service through IRSA. So this is how we can set RBAC permissions and IRSA on our Kubernetes resource. And this is so much important and hot topic while if we want best security in our Kubernetes. The fourth one is define network rules between pods at Kubernetes network layer using a resource called network policies. So at the end, what happens in Kubernetes, that there will be two pods will be communicating, right? Or maybe maybe user will be accessing that pod. So we should have network rules inside that from this network only that pod will be accessible, or this front end pod only able to access this backend pod only, not other pods. So that can be done through network policy. This is the resource available in Kubernetes that we can use to restrict these parameters. The fourth one is enable TLS between pods, so that all the communication will be encrypted. So right now, like by default, Kubernetes don't provide any TLS communication between pods. It's plain text, so it is very easy for hacker to intrude the pod. So once if hacker got access to one of the pod, definitely that hacker will able to access other pods as well through that particular pod. So there is a thing, we should enable TLS between pods, so all the communication will be encrypted. So again, the next topic, like service mesh, we can use over here to enable TLS communication between all the pods. Also, we can have observability over there. So this can be other topic for in a coming videos, that is service mesh. Okay, the next one is security secrets, by enabling secure your secrets by enabling encryption using encryption configuration resource. So securing secrets, so secrets are nothing but objects, like there we have one secret object in Kubernetes, in that we can store our credentials or any API, uh, what we can say, the API password in the form of base64. So if that secret object is not secured, so definitely anyone can read the secret object, can find all those base64 encoded credentials, and can decode as well using base64, because that is so much easy to decode using base64. So definitely there will be a breach if there are some database passwords are there, and other security credentials are there. So we should enable encryption using encryption. So there is another resource in Kubernetes that is called encryption configuration. So that can be used. So it will encrypt your secret by using some encryption key. That's the thing, we will have to manage that encryption key somewhere. Either we can go for AWS KMS, or we can have a HashiCorp vault in place. Okay, the next one is secure etcd store by putting it behind firewall and encrypting whole etcd data. So etcd, we can say that it is the brain of your Kubernetes cluster. So whatever deployments, whatever objects go into your Kubernetes, that's metadata is stored in the etcd. And if that etcd is breach, so definitely the hacker will able to get all the deployment data, all the application data from your uh, Kubernetes cluster. So what we can do, we can put that etcd behind firewall. So from outside internet, no outside world, nobody able to access the etcd data. Or we can encrypt the whole data again through some encryption key that we can do. The next one is define security policies to enforce specific configuration. Like uh, sometimes what happen, we know developers and DevOps are two different entities. Definitely DevOps may have more knowledge in Kubernetes, but developer may not have. So sometimes what happens, developer deploy application, like the second we talked, that is run container as a non-root user. So by mistake, or maybe because of lack of knowledge, developer may run that container as a root user only inside your Kubernetes. So to enforce such specific configuration, like that don't that example, like don't allow pods that run containers with root, or network policies should be defined for every pod. So this can be done using security policies. We can set these rules, and if these rules are passed, then only that particular pod will be deployed, otherwise that pod will be restricted. So these are the some security Kubernetes security best security policy, I would say, we should implement in our Kubernetes. Next one is auto scaling. So it is strongly recommended that you leverage benefits from Kubernetes auto scaling mechanism to automatically scale cluster services with a surge in a resource consumption. Like we have horizontal pod autoscaler to, like we already right in the beginning we talked about resource limits and resource requests. So definitely once the resource limit get passed, that pod will end up into evicted state. So to avoid that as well, we can have horizontal pod autoscaler. So we will define a threshold, like if CPU goes more than 80%, the next replica will come in. So it will just increase the replica using the horizontal pod autoscaler. The next is cluster autoscaler. So we can upscale, descale our nodes as well using cluster autoscaler. We will have threshold. Autoscaler will continuously check for what are the pods are there which are unscheduled because of there is no resource on our cluster, or node capacity of pods is fulfilled. So there we can use cluster autoscaler and horizontal pod autoscaler. So if you so definitely we can maintain our load at the optimal level, and we can avoid capacity downtime if we use auto scaling. The next is monitoring your Kubernetes cluster. So monitor the Kubernetes cluster sprint. So you should because the main entity of your Kubernetes cluster is control plane, right? And what control plane includes? Kubernetes API service, kubelet controller manager, etcd, kube proxy, and kube DNS. These are several components are in a control plane, and that has to be monitored, because monitoring your control plane will definitely help you to identify issues, threats within the cluster, and will increase its latency. The next part we would like to monitor, that is high disk usage. Like for every worker node, definitely will have some root volume or extra volume attached, because at the end, worker node uses Docker, and Docker uses images, so images will be stored on your worker nodes. So we should have monitoring in place, and alerts also should be in place for our root file system and all the disk volumes associated with that cluster. Last, that is audit your logs regularly. So in Kubernetes, auditing the logs regularly is very important in order to identify any vulnerability or threat in your cluster. So it's too simple, like all the request data made on your Kubernetes API store in the audit.log file. You just have to enable that in the audit-policy.yml file, and then you can monitor that audit.log file from var/var/logs/audit.log. So these are the, I would say, best practices we would recommend you to follow while working with Kubernetes. That's it for today. Thank you.
If you like this video and want to learn about more Devops tools, then subscribe Doremonlabs. Doremonlabs, a perfect Devops partner.